Hello everyone and welcome to .NET Core Central. In last couple of videos, I spoke about Saga Orchestration, and then after that I also discussed how to implement state machine using simple switch condition as well as using the stateless NuGet package. In today's video, I'm going to mix everything up to create a Saga orchestration engine using stateless state machine. So to discuss that, I'm going to use the same example that I used in my Saga orchestration video, where we are going to implement an order entry. And as a part of the order entry, first we are going to create an order, then we are going to update the inventory, and then finally we are going to send the notification. And in terms of the Saga distributed transaction, we are going to implement an order orchestrator. And the main responsibility of the order orchestrator is to first call the order API to create an order. If it is unsuccessful, then just send a response back. And if it is successful, then create an inventory. If the inventory creation is successful, then just call the notification API to send a notification. But if the inventory creation is unsuccessful, then use a compensating transaction to roll back the order and send the response back. And if the inventory creation is successful, then send a notification calling the notification API. And if the notification sending is successful, then send the response back to the UI or retry sending the notification. So that was the overall idea of implementing distributed transaction using Saga orchestration. Now, one thing I want to mention that for the example that I am doing, I am using Web API or RESTful microservices. But the same Saga orchestration can be implemented using asynchronous microservices, implementing a queue or a stream. But for simplicity of this example, I am using the RESTful API. So now let me get back to the project. And this is the solution that I have. It has 4 RESTful services. The first one is an inventory controller. Right now, I am just returning a number. There is no logic here, but this is the service which will be responsible for updating the inventory. And if the inventory update fails, it is going to throw an exception, which I will show using just throwing an exception here. The second one is the notifier, which is responsible for sending notification, which will be either email or text message or any other form of notification. The third one is the main order controller, which will be responsible for creating or deleting an order. Similarly, inventory controller also will have a create or delete inventory for rolling back the inventory. The order controller has create as well as roll back of the order. And then finally, I have an order orchestrator. And in my last video, I just used inside of the controller of the order orchestrator, I used HTTP calls to just call all the services and show how the distributed transaction is going to work. Today what I did is I copied the code for all the proxies and moved to their individual classes. So we have an order proxy, which is responsible for creating order. We have a notification proxy responsible for sending notification. And we have an inventory proxy, which is responsible for creating inventory. And then what I did is I have also added the stateless NuGet package for implementing a state machine. And for the state machine, I created an order manager. I have not implemented any code yet, which is what we are going to do right now. But I just implemented a class called order manager, which has different state for this order transaction and different action we can perform. And a constructor which takes the order proxy, inventory proxy, and notification proxy for managing the distributed transaction using a state machine. And then finally, I updated the startup to register all the newly created classes and interfaces. So now let's get into the order controller. And what we were doing in the order controller is first we were creating an order, then an inventory. If an inventory creation failed, then we are rolling back the order transaction. And finally, we were sending the notification back. So what I'm going to do is I'm going to get rid of all this code as we are not going to need them. And here I'm going to get rid of this HTTP client factory as we are not going to use it. And I'm going to add here the I order manager class. And here I'm going to say response equal to and I just got rid of the order ID, though we could pass the order ID from that method, but for the time being this method just returns a boolean. So that's what I have. This is not an asynchronous method right now, but we can create it as an asynchronous method. So I'm going to get rid of this task because it's not needed since it's a plain method. Okay, so this method is ready. Now let's go and implement the order manager. So just like my previous video where I showed how to create a state machine using the stateless, now I'm going to create a state machine for this entire order orchestration. Now if you have not seen my previous video, I'll strongly suggest you go and see the video. I'm going to provide a link in the description, but let's create an order state machine. And the state machine always take the state and the action, and the state we are going to use this state, which is order transaction state, which has not started as the initial state, and then order created, order create failed, order cancelled, inventory updated, inventory update failed, inventory rolled back, notification sent failed. And in terms of actions, we have create order, cancel order, update inventory, rollback inventory, and send notification. We could also add retry notification so that we can retry the notification when notification sent is failed. So this will show all the possible state and all the possible action for the state machine. And for the initial state, we are going to set it as not started. And finally, for the return, we want to return true only if notification is sent successfully. So for the return statement, we can say so we can send order state machine.state is equal to notification sent. And as I mentioned in my previous video, after we create a state machine, the state property will always give the current state of the state machine. So our expectation is at the end of this whole function, if the state is equal to notification sent, then this was a success, and that is what we are going to return. So now let's start configuring the state machine. And as I discussed in my last video, we use the method configure to configure a state and then permit to allow the action that has to be taken. Now, the first state that we are going to start with is not started. And on non-started state, the action which will be allowed is going to be create order. And when a create order happens, we want to call the order proxy to create the order. And based on the status of the order creation, we either want to set the state of the state machine to order created or order create fail. So how we are going to do that? So for that, we are going to use two methods of the state machine. The configure to configure the initial state, and then for permit with the logic, we are going to use permit dynamic. So let's show how to do that. So here the permit dynamic takes the state which can be permitted and an action which will be executed when that particular action is triggered. So for this one, what we are going to do is we are going to call the order proxy to create the order, and the order proxy returns a tuple of int and bool. So does all other proxy. So what we are going to do here is we are going to take the order ID and is success is equal to so as you can see here, I am just doing a result and not using await. Using result is usually not the best practice, but given that the overload for permit dynamic does not have an async action, so I'm just using dot result here. And then finally we are going to return if it is success, then order transaction state dot order created. Otherwise, if it is not success, then we are going to send the state as order create failed. So that would cover the case for not started. Now after it is not started, now we are going to configure order created state. What is going to happen when the order is created? For that, so for order created, what we want to do is we want to permit update inventory, and when an update inventory action is triggered, we want to call the update inventory method, and if it is successful, we want to set the state to inventory updated. If it is a failure, we want to set the state to inventory update failed. So for that, we are going to again use permit dynamic. Actually, let me just copy paste this code and change some of the implementation. So I'm going to copy paste this, and here instead of create order, it's going to be update inventory, because that's the action which is permitted when the order state is order created. And then instead of order proxy, we're going to use inventory proxy update inventory, and this can be inventory ID. And just like before, if it is success, then we want to set the status as inventory updated, and if it is failed, then inventory update failed. These are the two possible state. And then what we want to do is, if the order is created successfully, we also want to trigger the update inventory, right? We want to fire that event. We don't want to do it as a part of the code here. We want to do it only when the order is created. So for that, we want to capture the on entry state for order created. And to do that, and if you look into my last video, you'll get a very good idea of what is the purpose of on entry. But just to give a quick overview, on entry is triggered when the state of the state machine enters a particular state. So we want to trigger the on entry when order created state is entered, which means the order creation was successful. So for that, what we are going to do here is we're going to do on entry. And on entry, we can just execute a particular action. So here we're going to do order state machine dot fire, and here if the order is created successfully, we want to fire order action dot update inventory. So we're going to say order action dot update inventory. That's the action we want to take when order state is created. So similarly, we are going to take care of the inventory updated. So for that, what we are going to do is I'm going to just copy paste this code and say status is inventory updated, and in case of inventory updated, allowed action is send notification. And in case of that, what we want to do is we want to use the notification proxy dot send, and here it's going to be the notification ID, and then either the state is going to be changed to notification sent or notification sent failed. This is the two possible condition. And on entry here, we want to trigger the send notification. So these are the three possible state, right? The thing that we did not consider, and I'm going to put the breakpoint so that we can show how this whole thing works. And then finally, we are going to do order state machine dot fire, and it's going to be create order, because that's where the entire state machine starts, right? And if the order creates successful, create order is going to be allowed for not started, which is the initial state, and it's going to trigger this function, which is going to either have order created or order create failed. Order created will trigger this, which will either have inventory update or inventory fail. Inventory update will trigger this, which is either notification sent or notification sent failed. Now, if you remember in our diagram, we still have this scenario which we'll have to take care of. So if the inventory creation is success, we're sending notification right now. But in case of failure, we are not sending a rollback. For the order, it will happen because if it is failure, we are not capturing any state. So it will automatically go into the last line and will return false. But if inventory creation failed, we have to roll back the order. This is something we have to take care of. So let's go and take care of that. And for that, what we are going to do is we are going to handle the state. So we're going to say dot configure, and the state that we want to handle is inventory update failed. So inventory update failed, and for the inventory update failed, we want to permit the action rollback inventory. And what we can do is we can make it as permit dynamic, and here when rollback inventory is triggered, in case the inventory update is failed, our state has to be inventory rollback. That's the state. So we can just return inventory rollback. So we get into this state, but along with that, we want to actually roll back the transaction. So here we can say order proxy dot delete order, which I have not created. Let's just create a function here. Public void delete order for the time being, and just put a console.write line. For this method, of course, we need to pass the order ID, which means the order ID here, which is the initial order ID, has to be kept in a state outside so that it can be passed along. So I can quickly do that. And here, ideally, we should be calling this same thing. Now we can do that. For that, we just have to create the order client, and we can just do send a call to delete async dot result, and just that's about it for the time being. But as I said, this is not the right way of doing, but just for simplicity and interest of time, I'm doing it this way. We just call the delete async and delete the order. And in the order manager, we can just create here order ID, and we can just so this way we can just take the order ID from here and is order success, and we can use that. And then when we had to do delete, should be adding this method to the interface. And now we can just do a delete order, pass the order ID. And then after this, we return the state as inventory rollback. And then here, what we have to do is, remember, we have to trigger when an inventory is failed, we have to trigger the rollback order. So we'll do on entry, and on entry, we are going to do order state machine dot fire. And for the fire, we are going to do order action dot rollback inventory. So that is what we're going to do. And then finally, the other state we have to consider is inventory rollback. So now that inventory is rolled back, we have to cancel the order also, or delete the order also. So this code is wrong. This should have been inventory dot delete, not order dot delete. So inventory proxy dot delete, and it will take the inventory ID, but I'm not changing it now. And inventory proxy doesn't have a delete method, so I'm just going to quickly add a public void delete. And here I'm just going to do console dot write line deleted inventory, just for the interest of time. But as you can see, you can put all the business logic in that delete method. So now here we're going to do inventory proxy dot delete, because that's what we want to do. And similarly, we are going to just copy paste this for the final state of inventory rollback. When the state is inventory rollback, the only action which is permitted is cancel order. And for cancel order, we are going to do order proxy dot delete order, and here we'll pass the order ID, and the state will be at this point order cancelled. And on entry of the inventory rollback, we are going to fire this cancel order. So now this creates the entire state machine, and I'm going to walk through it so that it is pretty clear to everyone what is going on here. Just so that, because I just written the code, I just want to reiterate once more time. So initially the state is not started, which is here. And when the state is not started, the only action which is allowed is create order. And on create order, we are going to execute the create order. And then if it is successful, the state is going to change to order created. If unsuccessful, order create failed. And the create order is triggered here as the fast action. And then when the state is order created, on entry, we are going to fire update inventory. And order created state can only permit update inventory. And on update inventory, we are going to update the inventory using the inventory proxy and set the state of the state machine to either inventory updated or inventory update failed based on the success or failure. And if the inventory is updated successfully, then we are going to, on entry, we are going to trigger a send notification, which is going to permit the send notification action, on which case we are going to send the notification to notification proxy. And on success, it's going to be notification sent. On failure, it's going to be notification failed. And then finally, we are covering two other states, which are inventory failed and inventory rollback. So when an inventory failed, what we want to do is we want to delete the inventory, and we are going to set the status of the inventory to inventory rollback. And then when the inventory is rolled back, we're going to go and we are going to cancel the order and then set the state of the state machine to order cancel. So that is the whole state machine. And now what I'm going to do is I'm going to run this application, and all the other services are running in a console application, in a tabbed console application here, all the three services. So now I'm going to start this Saga Orchestrator, and once it's started, I'm going to go to the order API, try it out. This is immaterial, so I'm just going to keep the product name as string, doesn't matter. Execute. So it comes to the state machine, and then it goes through all the configuration here. And then finally, the create order state is triggered, and the order is now created. So it fired the update inventory. So it came in here. Now we'll try to update the inventory, which is a successful. So we'll set the status to inventory updated. And then now it is going to come to notification. Notification status is successful. So it will just create the notification and then come out, and it is going to be a success of true, right? Now what I'm going to do is I'm going to go ahead and update the inventory controller to throw an error. and I will restart the inventory controller as well. So here I just restarted the inventory controller. So next I'm going to start the Saga Orchestrator again, and I'm going to try it out one more time. And this time I'm just going to do F5. This time first thing we are going to do is we're going to call the inventory updater, and this time it's going to be a failure. So inventory status will be update failed. Once update failed, it's going to come here, it's going to delete the inventory, and it's going to set the status to inventory rollback. And once inventory is rolled back, it is going to handle here to delete the order for the order ID, and then it is going to set the status of the order to cancelled. And finally it is going to come here, and the state of the state machine is order cancelled, whereas we were expecting notification sent. Hence finally we are going to get a false as the response here in the body. And as you could see, we rolled back, or we applied the compensating transactions for the distributed services. So this is how you can implement a Saga orchestration pattern for distributed transaction using a stateless state machine. Again, if you just watch this video as is, it's going to be a little hard to understand this whole state machine configuration. So I would request again to go back and watch the stateless state machine video that I did last week, and also go back and watch the Saga orchestration engine that I did without the state machine. So that's all I wanted to cover for today's video. If you like this video, please give me a thumbs up. And if you are new to my channel, and if you think you are getting value out of my channel, please subscribe to my channel. And thanks so much for watching this video.